Assalamualaikum and hello to everyone. My name is Nurhazani Fatin and my supervisor is Professor Dr. Hidayatul Fatih. My final year project is about effects of radiation on biological parameters of male Aedes aegypti. So first of all, let's see the dengue cases in Malaysia. From 29 December 2019 until 10 March 2020, the cases recorded were 29,766, and the highest one is in Selangor, which were 18,306 cases recorded. From this table, we can see the comparison between cumulative dengue cases until week 12 of 2020 and 2019. In 2019, about 34,222 cases recorded, while in 2020, about 32,951. So there is a slightly decrease in dengue cases in Malaysia, but they are not too much actually. So this picture was taken from the Star 2019 from our local newspaper, talking about how can we control this mosquito population. And also the Star mentioned about the sterile mosquito method, which proved to fight against dengue. So from the previous slide, I have mentioned about sterile mosquito method. So this is what it's all about, sterile insect technique, SIT, which is environmentally friendly insect pest control method involving the measuring and sterilization using radiation of a target pest followed by area-wide release of the sterile male by air over defined areas where they met with wild female, resulting in no offspring and a declining pest population. So this is the literature review. Aedes mosquito responsible for transmission of dengue virus, which is now becoming a very major global health emergency. And the second one is that the flying mosquito within the treated area are killed through fogging. Although the local mosquito population is reduced for only a few days, the fogging actually does not really prevent the mosquito from re-entering the area, meaning after a few days, this population of the mosquito will be increased and will start to enter the area again. And also there is a development of resistance to insecticide due to the constant use of insecticide to the environment. And this method may have been effective in the past, but now currently due to the unplanned urbanization and the construction, this control method of dengue is becoming more challenging to all of us. So as for research justification, Aedes is the main vector of dengue virus transmission through female biting on the human skin. And now this dengue fever has become a real major health problem here in Malaysia. So the Special Program for Research and Training in Tropical Disease and the International Atomic Energy Agency, in partnership with the Food and Agriculture Organization of the United Nations and also World Health Organization, have developed interest in testing the sterile insect technique for Aedes mosquito. As for the research question, does effect of radiation can change the biological parameter of male Aedes aegypti? And research hypothesis, radiation effectiveness can change the biological parameter of male Aedes aegypti. For my general objective is to study an effect of radiation on male Aedes aegypti. As for my specific objective, I have three of it. So the first one is to determine the mating ability of male Aedes aegypti from different sources of radiation, which are cobalt-60 and cesium-137. The second one is I want to evaluate the fertility, fecundity, and longevity of irradiated male Aedes aegypti. And for the third one is that I want to identify and compare the effectiveness of different sources of radiation towards male Aedes aegypti. So this is the methodology. The study design is experimental. So first I will do the mass rearing of Aedes aegypti using available strain in Insectarium at UKMKL. Then I will separate the female and male pupa. So the male pupa age of 5 days will be transferred into 5-liter beaker containing water. This male pupa will be irradiated at Malaysia Nuclear Agency with 55 gray. That is the dose suggested by Institute of Medical Research. So this male pupa will be exposed to cobalt-60 and cesium-137. Later on, this irradiated male pupa will be transferred into cage, and at least after 2 days will be emerged as an adult. Irradiated male is mated with non-irradiated female of the same age. This process of mating will take about 3 days. Then I will give the blood meal to the mosquito, and the irradiated female will be separate and isolate individually in shell vial with water and filter paper for oviposition. And I will observe the biological parameters. So this is the biological parameters. The first one is the longevity, which I will remove and count that of the mosquito at 24 hours interval. But as for the weekend, I will collect the data between the interval of 48 to 72 hours. And if there is any two-per death occur, so I will immediately discard the cage. And this whole process will take about 14 days. And then I will calculate the average lifespan of the mosquito. For the second one is the fertility, which the eggs will be obtained from the individual mosquito from the vial, and the egg will be incubated about 72 to 74 hours, and I will count the newly hatched larva for straight 7 days. Fecundity is basically I'm going to count the number eggs laid per female. So for the statistical analysis, the first one I will be using descriptive analysis because I just want to determine the mating ability. And also for the second one, I will be using also descriptive analysis because I just want to evaluate the biological parameter. And for the third objective is that I want to identify and compare the effectiveness of different sources of radiation towards male Aedes aegypti. So I'm going to use the PET-T test. So this is my dummy table. Basically is how I'm going to collect the data soon, roughly. So the first one is objective one, descriptive analysis. how I'm going to determine the mating ability. And the second one is the biological parameter, longevity, fertility, and fecundity. And the last one is my objective 3, PET test. Between this cobalt 60 and cesium-127, I'm going to see the effectiveness of the sources, which I'm going to compare the mating index and these three biological parameters. So this is the Gantt chart and my reference.